Morning, everybody. Today is your first lesson of the new hire course. You should have already watched the introduction to the hire course video, which just tells you about how the course is going to work. And today's lesson is going to focus on 4 main tasks from the climate change topic. You're going to need, obviously, the main assignment for this week open, which may have been what you've opened in order to get to this video link. If you got through it directly from the main tab, then could I suggest that you open up the assignment and have a look that you've got access to all of the different tasks? And can I also ask you to open up your main student copy of the climate change topic notes, so you've got that to start answering as soon as the lesson is finished. You can feel free to go through each of the tasks as I talk about each one and answer them, pausing the video, and then continuing on with my lesson when you get to the next task. It's entirely up to you how you want to do the work. Today's lesson is for this week, starting the 20th of April, and you must hit the hand in button by the 30th of April, so it can be marked. There are 4 tasks that we're going to be looking at today, and they all are leading into the causes of climate change. Now, before we even get to the causes of climate change, if we just scroll down to the second main page of our students' notes, we have to deal with actually what is the problem. Okay, is it a problem in the first place? So therefore, why study it? And if it is a problem, what's actually happening? So the first key thing we have to establish is the planet actually warming? And what's the evidence for current warming? And if we have a look at this graph in our main student notes, we can see that the temperature of the planet from 1900, so over the last 120 years, has varied noticeably, going lower during this period of time, but also peaking in the 1940s. But since around about the 1970s, we can see it has heated up considerably. Of course, when we talk about temperature changes, we are talking about a baseline for the last sort of 30 years. We always work on 30-year averages. So how does the average of 1 year compare to the average for the last 30 years? And when we talk about temperatures, we're actually talking about the average for the whole planet. So that is the temperature in every part of the planet, from the Arctic to the equator, from the coldest areas to the warmest areas. We have weather stations recording this everywhere across the planet. Now, if we just have a look at what your task actually is in regards to this first particular piece of work, you are going to be asked to describe in detail the pattern of global temperature changes since 1900, and then describe the pattern in detail of carbon dioxide changes. And then you're going to be asked to talk about the relationship between those two, pointing out the evidence for that. Now, of course, remember from National 5, describing in detail requires you giving key dates, talking about amounts. When you're talking about amounts, you need to talk about whether these are amounts below the zero or above. Zero being the long-term temperature, average planetary temperature. You want to talk about whether it's stable, whether it's declining, whether there's a short-term peak, whether it's accelerating, so talking about general trends. Is there any period of time when there is something noticeably different from the average trend? So, for example, around about here in the 1940s, we can see the temperature rising substantially by about 0.25 degree over the actual carbon dioxide levels, which were actually not rising during that particular period of time. So that's what we would call an anomaly. It doesn't fit the general trend. Likewise, in the earlier days, we can also see that there's quite a bit of difference. What we can see, though, is largely from about the 1960s, the upward trend in temperature matches quite closely the rapidly increasing upward trend in CO2. When you're reading this graph, you also need to remember that whilst we're talking about temperature in degrees centigrade, when you're reading the carbon dioxide line, you've got to talk about the right-hand scale, and that's parts per million. So parts per million is the number of carbon dioxide molecules for every million molecules in the atmosphere. So that's how we measure it. Okay, so you might want to pause now. That's these 3 tasks, and you should answer them in your class notes here, and then move on to your next task. So our next task relates to this key idea. So if we have a little look at the assignment, we can see that we are looking at this, how can we actually prove it's happening? Now at this point, just like before, there are some twig videos I'd like you to watch. And can I just say, when you first of all click on these twig videos, you do need to make sure you've signed in using the Google part of the sign in for Twig. I'll just show you that. So you sign in this way here, rather than trying to enter your username and password. That will not let you in. But if you sign in this way and then use your school username and password, you'll be able to log in. Okay, how can we prove it's actually happening? Well, we need to rely on certainly the graph here that we just looked at, a kind of a 120-year pattern, but that's not really good enough to establish long-term changes. Because when we talk about climate and the planet and how long it's been here, we're talking about 4.5 billion years. And if we're trying to prove that there's a problem and that humans might have something to do with it, we need to establish that the rise of humans on the planet and the significant rise of humans is only going back about 5,000–6,000 years. Whether our arrival, and certainly our arrival since the Industrial Revolution in 1800, has had a substantial effect on global temperatures. Is the planet actually warming, or is this just part of a natural phase? So the first graph here for the last sort of 140 years does show us some really interesting evidence. It does show us a flattening between 1940 up to about 1916. We've already talked about that in the previous graph. It does show peaks as well as troughs down here. So there is a kind of a little mini ice age where it was almost 0.8 below that global average temperature. But to really establish whether this is happening, we need to go right back in time and start looking at longer term trends. So if we go back the last 2,000 years, here we can see the last bit of the graph above. So this sort of last 180 years is represented sort of here. But here we can now see we've got a little ice age from about 1600 through to about 1800 when the planet was much cooler. We can also see we had a medieval warming period, especially around about the 10th century. So the planet has fluctuated. We can see some peaks above the zero, right about around the time of Christ, right through a number of peaks up through the first 1,000 years. From about that point forward, though, we can see it's been substantially below. And what's really noticeable when you look across the last 2,000 years is what's happening in the last couple of hundred years. This line is extremely rapidly rising. And there's the kind of 1940 to 1960 point when it stalled. If we really want to establish evidence, though, is this sudden rise really noticeable? We need to go back a long way. So to do that, we need to go back 150,000 years, which is what this graph is showing. And we can see that around about 12,000 years ago, the temperature change, we had at the end of the last ice age, it was much warmer, and that's what triggered the last ice age. So here is the last ice age. Then we have this sudden warming, and that brings the end to the last ice age, or what we call an interglacial, because some people argue that we're still in the ice age, which is true, strictly speaking, as we have ice on the planet. What we can then see is this huge fluctuation over from 100,000 years to 50,000 years ago. Around about 2,000 years ago, we can see a rapid rise, and then it's been getting incredibly intense in recent years. And this last little bit here, we can just see at the very edge is a sudden rising. But is what we're experiencing right now noticeably different? Well, in the context of the last 100,000 years, without a doubt. We can, however, find out in history that there are times when the planet has been as warm as it is right now. And there are also actually times when it has it's been even warmer. What we've not seen, or we can't find evidence, is the actual angle of this graph. We have never seen such an unprecedented rapid rising in temperatures, or certainly we can't find evidence for that. Now, once you've read the work that goes with this page here and had a look at these graphs, I'd like you to now answer this question, which is considering the short-term, the medium, and the long-term evidence that the climate is changing. And you've got to talk about rises and falls. What What do you think is the best evidence? What's the overall trend in variations? Should we rely on the short-term evidence for the last 200? Do we go with the last 2000 when we think about medium? Or do we go with even longer-term evidence and go back 150,000 years? Of course, there is a problem with longer-term evidence. We're not completely sure how accurate the longer-term evidence is. And therefore, when we're trying to make judgments about what's happening, it's much safer to rely on more recent evidence than it is on older evidence. But it does appear that the current pattern, as you can see, shown by the last couple hundred years, does suggest something happening in the last 30 to 40 years that we should take note of. Once again, when you're describing data trends, make sure you talk about how rapid they are, talk about sudden changes, pick out dates in your analysis, and make sure you talk about all three graphs. Do also offer your own opinion about what you think is the key piece of evidence and why. Okay, that's the second task. You can pause now if you want, or you can continue with today's lesson. We're going to look at the actual evidence. How can we prove this is happening? Now, this is where it gets really interesting, because we're talking about temperature changes that go back 150,000 years. As a matter of fact, we have evidence of the climate over 4,000 years ago. And I'd suggest you, first of all, read this first little bit. You can have a little look at these three main bits of climate evidence that we have. We've got paleoclimatology, archaeological and historical, and modern scientific data. If we actually have a look at the assignment, we will see that I've asked you to watch 3 videos for evidence. And there's a really interesting one on using beetles to prove whether the climate's warmed in the past, as well as a couple of videos on using ice cores to establish the long-term changes in the planet's temperature. What I'd then like you to do is answer this task, which is explain 3 pieces of evidence, and that is an explain question. So that's, you've got to give the details. They help us determine that the climate has changed in the past. I'd like one of them to be to do with ice cores. So I'd like to focus one of them in how does the ice from Antarctica and Greenland help us establish the temperature of the planet more than 100,000 years ago. Okay. And give as much evidence as you can. You can use some diagrams if you want. You can pop some images into your notes, but make them quite detailed and do some thorough research. When you're looking for ideas, just you can have a look at some of the ones that I've got in this little table, or do your own research. But the whole idea here is for you to actually prove that we know what the temperature was 400,000 years ago, because of course clearly we weren't there. So how do we know the temperature was different? Right, you can now pause if you want, which brings us to the last part of the lesson, which is the fact that the planet's temperature is rising, but it's not rising evenly. Now, if we have a little think about what the actual task is, I'd like you to watch this video, which talks about the changing temperature across the planet, different parts of the planet. And you'll see in this video that some areas are warming at different rates than other parts of the planet. And if we actually look at the main notes that go with this, I've put this map for the most recent sort of 4-year period between 2008 and 2012, which shows that there's areas around Antarctica which are actually showing a bit of global cooling, whereas the Arctic is showing noticeable global warming up to almost 2 degrees above the long-term average. So we don't have an even pattern, which is kind of worrying. What I would like you to do in this task is just describe this pattern. And remember, when you're describing a pattern on a map, you've got to talk about areas of the world. This could be continents, this could be oceans. Are we talking about the east, the north, the south, the west? Not of the map, but of an ocean. So it's the South Pacific, for example, down here is very cold. The Arctic region is got a huge amount, is much warmer than the planetary average. Areas that are roughly only small mild changes are in the equatorial regions, South America and Central Africa. But we can see significant 1 degree warming in this area of the Sahara. So that's how you want to go about describing it in your task here. And once you've completed those 4 tasks, please hand in your student notes set for marking of your 4 answers. You'll get some feedback. You'll get some model answers to the questions that we asked. And that will set us up nicely for next week's lesson, which is going to be looking at the physical factors, the human factors, and establishing what the greenhouse effect is, as well as beginning some work on the consequences of climate change.